Welcome everyone to Dev Talks. My name is Partha Banerjee and I'm here on behalf of the GNU Linux Users Group, the official open source and development community of NIT Durgapur. And we have a very special guest with us here today. He is the current Director of Business Automation at Digital Expert, Mr. Alex Bunardzic. Welcome, Alex.
Thank you very much, Partha. It's good to be here. I appreciate the invite, and I hope we'll have a good time in this session.
Absolutely, Alex. So, would you be ever so kind as to give our viewers a quick rundown as to what your daily responsibilities and roles are at Digital Expert? What is it that you work with?
My focus is on transforming teams to adopt a different way of working when building software applications. And I'm kind of seen as the agent of change, where I can try and inspire people and convince them that there's possibly a different, possibly better way of working, and also to open up for people to try and experiment and not necessarily try a one size fits all, but find the most optimal way for the team to work, given the context, given the situation, and how volatile or predictable their day-to-day work environment is. So I don't have like a formula or something set that I can just sell, but I need to work with teams and I need to kind of help them and try to lead by example and draw on my, because I have a lot of previous experience and I've been in different roles and experienced different aspects of our profession. So now we are learning, not just me, but my peers and people who are ahead of me, we're learning that there's definitely room for improvement. There's definitely a way to work better and deliver more value and also be more satisfied at the job, daily job, and feel like we are fulfilled in our profession and that we are growing our career and the future looks bright. So that's where my focus lies in trying to uh, work with teams of software engineers or software developers and get them to the point where they can find a better way for them to work.
So it's basically about really pushing the industry forward, isn't it?
Yeah. Uh, for some reason, our industry, meaning software development or software engineering, is kind of lagging behind because we haven't had much of a breakthrough in the past 60, 70 years. Anything you hear about today, you can, if you go and read the history, you can find, oh, it's already been done in the 1960s, right? So it's almost like we are rediscovering some old ways of doing. And we are really not right now in the need of making a more breakthrough, right? Because I think when you look at the advancements in hardware and other areas, it's way ahead of software. The software is kind of lagging behind, kind of stuck in a certain rut, not moving fast enough. And we are looking for ways to remove those roadblocks or bottlenecks, and for us to pick up the slack and start making a quicker progress. But because we need a lot of progress in this industry. Yeah.
But I guess it's safe to say that you work with multiple teams of software engineers working on a single or multiple projects, right?
Yeah. Although I'm not solely responsible for that, right? There are other people in similar roles, and we cooperate and collaborate. But yeah, it's true that you can. It's very hard to be in a position where there's just one team working on one thing, and that's it. It's oftentimes there's different aspects of the business, and different teams are working on different areas. But at the end of the day, it's just one. It should be like one business, one operation, and one delivery to the customers. Yeah.
So you talk about one business and one operation, and that actually reminds me of this certain thing that I've read about previously, which is known as mob programming. So, do you have any experience with mob programming? Can you please give us a rundown of what mob programming is?
Yes, I basically mob programming. I started with mob programming when I was in the position to lead what we call TDD dojo, test-driven development dojo. And dojo is a place where you practice your craft or your skill or your art. And it was an ideal situation to start introducing mob programming, which is basically uh, all the smart people focusing on one problem, one issue at the same time and solving it. This is similar in a way. If you ever been in a severity one situation, for example, if you work for some company and there is some kind of a defect or outage, and they call it severity one, and at that point they call all hands on deck. So basically, everybody jumps to fix that because otherwise the business will tank, right? So this all hands on deck, it basically means that we drop whatever we're doing and we are focusing on one critical issue, and we're all together in real time working on trying to solve it. This is what mob programming is. But in mob programming, it's not that life or death urgency. But every day we pick something that we think this is what is the most important thing to do today. What is the most? Is there something more important? Then we drop that. But we need to pick one most important thing, and then everybody joins and works on it at the same time. Mob programming is also called keyboardless programming because the person who is making programming decisions is not at the keyboard. So this is how it goes. There's one keyboard, there's one screen, there's one computer, and there's a number of people in the room. And the room could be physical room or virtual room. And then we kind of pick one person, or they volunteer to be the so-called driver. It's like driving the car. But this person is at the keyboard. The person at the keyboard or the driver, they're not making navigation decisions. The driver is just driving. The navigator is another person who is not at the keyboard, but the navigator could be standing next to the driver, like a person in the car who is navigating, right, reading the map, navigating next to the driver, giving the driver instructions, turn left, turn right, etc. And so in mob programming, the navigator is the person who is telling the driver, okay, now I want you to do this, I want you to do that, right? And then the driver implements it, but the driver is not making those decisions. And then also, there's a mob, or we can call it the peanut gallery, and also they can propose or suggest something and recommend some course of action. Mob programming, important thing about when we start the session, we agree that there is a bias for action, meaning instead of debating or discussing or disagreeing, we do not have any theoretical discussions. We can debate by making changes to the code. That's the only way. So action, right? Somebody says, well, I disagree. Well, don't talk to me about why you disagree. Just tell me what changes in the code you want to see. And then we make changes and see if it works. So it's bias for action. And then finally, the most important aspect of mob programming is rotation. So we set a timer. And in my case, I was fond of setting a timer to ring every 4 minutes, but that's just up to the team. So every 4 minutes, the timer rings, and then the driver gets up, and the navigator becomes the driver, and the driver becomes a navigator, and so it's like musical chairs. So we go around. So pretty much everybody in the session gets the chance to be at the keyboard, to be the driver for 4 minutes or longer. I don't know. Everybody gets the chance to be the navigator. And so this rotation is what basically creates this energy in the mob programming session, where it doesn't really matter who is smarter or less smarter, who is more experienced, less experienced. We work as a team, and the team comes up with a solution, not an individual, not the smartest person in the room, right? So that kind of changes the dynamics in the team, changes the outlook, changes how people feel in the team. Because all of a sudden, it's not competition among team members. It's the team is the smallest unit of operation, right? So I find it to be the most effective way of working and produces the highest quality of the code. I don't know if that answers your question. or if you want to ask more about
Absolutely does. Yes, yes, it absolutely does. So basically, it's not just about putting all of the minds on the same project, but also making them bond with each other, working as a single unit, right?
and bias for action. Everybody at any point in time will be jumping in and making some action. So it's not theoretical, it's not philosophical, it's not, oh, I disagree because I read somewhere. Well, let's try it in the code. Let's see if it works. If it works, fantastic. If not, we try something else. Um, but we do not, in mob programming, important thing is we never retrace, we never go back. We're always like continuing. If you make a mistake, we just keep going forward. The idea really, and if you do that, you will discover that the mob or the ensemble or the team quickly congeals into this almost like a mind share where everybody's really keen on solving that. And usually I like to say, look, guys, we will not stop this session until we solve this. But at the same time, there is a working agreement in the mob that at any point in time, anybody can just get up and leave. There's no like obligation. If you want to take a break, if you want to leave for the day, that's fine. The mob takes care of itself. It's kind of self-healing. It's not like, oh, if you leave, everything stops. It's not like a rock band where if the drummer leaves the stage, okay, we cannot continue with the performance. And because now we are cultivating this kind of in software, there's one discipline called distributed cognition, and software development is distributed cognition. So the knowledge of how to do things is distributed. It's not just located in one person. So I'm the boss and I know and nobody else knows and I just hold their hands. That's not how it works. And so this distributed cognition is happening in a mob session, so that it doesn't matter if somebody leaves or comes back. It's okay. It's not a big disruption. We just keep rolling with whoever is here with us, right? And that creates certain dedication, certain commitment, where indeed people are reluctant to say, okay, I'm tired, let's go home, if the problem hasn't been solved. We kind of feel like, yeah, look, we know we can solve it, and today we're going to solve it, right? So that's my experience. I'm not sure if anybody here on the call has similar or different experiences, but that's what I can tell you from my firsthand.
It's very fortunate that you have shared your experience with us. Now, you are talking about how teams perform together as a unit. Now, there's something I need to ask you on that. Since being college student, many of us start making our own applications or our own websites. Think of it as kind of a portfolio site. Now, what is the difference between when an individual solely develops an application, for example, a web application or a mobile application, as compared to when a large company does it working with a huge team? Except, of course, the budget. The company will have a more budget, but basically, the user and the company, they're using literally the same frameworks for making those things. So then, what differs them? What causes the difference?
The difference are, first of all, unless the team is doing mob programming, then people work on different things, and then after a while, these things need to be put together. Like if you're one person shop, you're the only person, then whatever you do, it's there. It's not somewhere else, right? But if you have a team of like 5 people and they are working on one, whatever it is, use a story or feature or something, then usually if they're not doing mob programming, they divvy up the work. They chop it up into 5 parts, and everybody goes away and does their own part. So on the surface, it looks like it's very effective because you're utilizing 5 people and they're working in parallel, right? But it's very deceptive because basically it's much less effective, because now when all these 5 parts have been finished, now these people come back and they want to put it all together, and there's all kinds of conflicts and things are not really gelling because they're working in isolation, right? If you're doing mob programming, that doesn't happen because everybody's right there, so everybody's clear what's happening, right? And it's kind of similar to when you're doing a solo project, right? There's a huge, not only overhead in putting it all together, but also there's a problem with putting things on the queue. So let's say you're working on something and you're done, you put it on the queue, which means you're asking somebody else to drop whatever they're doing and to attend to your request. So maybe you open a pull request or code review or whatever, something that you are hoping some other people will have a chance to look at. But these other people, they're also busy. And basically, when you put something on the queue, this opens up this kind of a wait time. And this wait time is unpredictable. Nobody knows how long will this be sitting on the queue. There's no way to find. There's no rule. And this unpredictability is what is the biggest problem in the large teams, large organizations, where there's a lot of queues and there's a lot of requests put on the queues. And and then they're sitting on the queue and everybody's like, hey, please, can somebody please review my request? And they're like, yeah, sure, but I'm in the middle of something. And also I'm hoping somebody else will review my request. And that creates unpredictability. And this unpredictability is making the business side nervous because they just cannot predict when is this going to be done, right? And then this now causes business to start micromanaging and breathing down people's necks and saying, well, where is it? Where is it? And so that kind of kills the morale, demotivates people, right? So it is a serious problem in larger teams and organizations is putting things on the queue and then looping. And even when you put something on the queue and somebody eventually says, okay, I'm going to review your code. Well, that doesn't mean that they will approve it. They may find some issues and it's going back to you. And then you can have many iterations of this like back and forth, right? So all these things are slowing everything down, are killing the flow. And the worst part is it's unpredictable. Nobody in the world can tell you how long will this take. Or if for that reason we introduce some really ironclad rules, what's happening is then people just gloss over and just approve half-baked things, and then you ship low quality, right? So there's this risk of either you let it, you leave enough time for everybody to thoroughly review everything and have their say, but then that creates this unpredictable situation that the flow is just not there. We just kind of stuck somewhere in no man's land. Or you can have some really rigid rules, but that means that we're cutting corners. We're just rushing things, and that's not good either, right? So that I would say that's the big difference. It's way more advantageous and less risky if you're doing everything yourself, right? But that's not scalable. That's just for small projects.
So for small projects, individual contributions may do, but for large projects, you would need a team working in unison, like gears, right?
Yeah. And again, the biggest problem when you have separate individuals being assigned separate tasks, queuing and unpredictable wait time, and also the overhead of putting it back together, avoiding merge conflicts, all kinds of issues. So it is a very tricky situation. And that's why mob programming is so successful, because it avoids all of that. There's no queuing, there is no reviews, there is no merge conflicts. Everything is in real time.
So, sir, in the tech industry right now, it is very important that people not only see what is going on in the present, but what may go on in the future. Like, what are the frameworks that people will be taking up in? What are the technologies that people will be exploring more? So, which brings me to a very nice thing that I have observed that in 2004, you worked at a company known as Chancery Softworks, and you were developing an educational software that was used in the entirety of North America. However, 2004 was years back. It was before Google, it was before YouTube. And I guess at that time, people normally didn't associate software with education as we do right now. So, what was your thought process while making such a product?
That was basically just automation of the workflow and paperwork. Not necessarily, it wasn't producing educational content, but schools in North America and probably everywhere else in the world, there's a lot of paperwork. You have to grade students, you have to, there's workflow, there's teachers grading, and then based on who passes, who fails, etc. So many of these things still have been done on paper, like paper and pen. And then schools were looking at more like a sophisticated, automated system software that will enable them to keep track of students, the exams, grades, and comments, and et cetera, et cetera. So it was in that regard, automating the paperwork and the workflow, administrative side of education, not content.
Also, while talking about mob programming, we were talking about this practice called TDD, so which is test-driven development. So, can you please just give us a quick rundown into what test-driven development is, and is it something that we as students should be thinking about right now to make our programming practices better?
Yeah, test-driven development is a very interesting thing because um, it is based on the idea that uh, when we are creating programs or we're creating software, writing software, the the way we do it today is we are using text. So code as text. Why? Because we humans communicate via language, like we're talking right now. And then we also learn how to put this in writing. And so even asynchronously, if you and I are not looking at each other talking, I can send you a piece of paper and something is on, and you can read text. And that's how we communicate. So to us, it's natural, and especially for engineers who are educated, they're all literal. The command of language is really good. So now when you have to communicate with a machine like a computer, in the early days, in the very, very early days, we were actually programming computers by physically rewiring, pulling the wires, and it was a very, very hardware approach. And then it was kind of really cumbersome and clunky and slow. So they introduced kind of an improvement, which was so-called punch cards. I don't know if you ever heard of punch cards.
Yeah.
Just a card, and in there you can punch some holes, and that card can represent some information. It could be instructions to the computer what operation to do, or it could be data, or both. And so the machines were enabled. You can have those punch cards prepared for the computer, and you put it in the computer, and the machine takes it, reads it inside somehow, and then follows the instructions, does some calculations, some transformations, some sorting and ordering, and then as the outcome of that, the machine produces another batch of punch cards, which would be your result or your report or whatever. So now you take that and you kind of read it. So that's how up until like maybe 1980s, that's how many companies were doing automation. But that's very not communicative, because if you take this card, you have some holes in it. It's very hard to understand, like, what is this, right? And so they say, look, we have to make something that is more human readable, that humans can understand. And so the decision was made to create that programming language, which will use some, at that point, English language is dominant in the industry, right? So English words, right? Such as if, else, and switch, return, and all these things. And so that made sense, because now we can write a program. We can understand, look, if this value is greater than this, then return that value, right? This is how you introduce some conditional logic, some branching logic, which is great for us humans. The problem is that computers don't understand text. They have no idea what text is. And now, when you give text to the computer, there's nothing a computer can do. It's clueless. So this text now has to be translated somehow, transformed into some machine code that the machine can execute. And that process of taking the text and turning it into something else and making the machine do something is introducing the delay. And so if I go, and I'm also talking about maybe earlier days, if I go and I open some source code and I make some change, I get no feedback, zero. I can make any change I want, and it's okay. No problem. It's only after I, try and compile it and build it and run it, do I see the effect of my change. And that lag is proving to be very detrimental, or it's not good for the quality of software. Unlike when we are making changes to physical objects, if I want to, if I'm working with a physical object and I want to make some change, well, the very material is going to push back and give me immediate feedback. It can tell me, oh, this feels like it's going to break, or I cannot push hard enough here. When I'm working with a software product, I don't get any pushback. I can go in, I can really mess up, and it looks like, yeah, nobody's complaining. It looks okay until it starts running, and then we see, oh, this is a big problem. So TDD addresses that situation. TDD is giving us a little bit more capability to get feedback earlier. And quick and early feedback is very important when we're building software. The longer it takes for us to get feedback, the less of a chance that what we're doing is going to be quality or will make sense. And we all know stories where somebody spends the whole day writing code, and then when eventually we start to run it, nothing works, and then spend 5 weeks trying to fix it and all that. Well, that's kind of foolish. So TDD says, look, first of all, we cannot, even though we think we're super smart, we cannot spend the whole day just writing some text and think that this is going to work. So first of all, let's be a bit more humble. Let's not be arrogant and think that we are smart. That's the first lesson, and some people agree to that, some don't. But us who agree with that, we go with TDD, which means first of all, we focus on very small steps. We call it tiny steps. So instead of having a big step, I'm going to now write a big class, and it's going to have like 500 lines of code. I'm not going to do that. I'm going to be very, very modest here and humble. And I'm going to take a tiny little baby step. And then with each step, I will check. I need feedback. I need the computer to tell me if my step broke something, if it's going in the right direction or not. So this is very, very deliberate, tiny little baby steps. That's the only way we feel we can work and produce quality. And us who are advocating TDD, we are very skeptical that you can just go away, sit in your room for 5 hours and come up with a brilliant, concept and brilliant code, and everything works. So it's iterate. It's kind of similar. I mean, it shouldn't be strange to people, because even in elementary school, when we are taught how to write essays and how to write whatever articles, we always have like a first draft, right? And then after that, you go and refine, and you go over and over your text until it becomes better and better. Same as with computer programming. You do your first cut, and it's very naive, and it's very kind of off the cuff, and then you go back, you refactor, you iterate. So TDD works in the following fashion. You come up with a very simple expectation, and you ask yourself, what is it that this system right now cannot do, and I would like it to do? Right now, it cannot do it. And then once you realize, okay, basically right now the system cannot apply order total discount. I want the system to be able to say, look, if, let's say this example, if the order total is greater than, I don't know, $500, then you have 5% discount. And we want that to automate that. So right now the system doesn't know how to do it. So the first thing I do is I formulate that expectation. So I'm expecting the system to do this. And this expectation is called a test. So first I write that test, and the test is saying, look, if I have order greater than $500, then I'm expecting the order total to be reduced by 5%. Now, when you have that executable expectation, and you're using some testing framework, depending on which language you're using, you need to see it fail. It's very important to start from a broken system, because if the system is not broken, you may feel like, yeah, everything's working, but you don't know, right? It could be false positive. But if you see that you broke the system, you know it's broken, and now you fix it, Now you know that from that moment on, the system will never break in that way because the test will always complain. So it's very important to always break the system and then fix it. So my test will fail because the system doesn't know how to calculate discount. Then I will make some changes to the code to make the test pass. I run the test again, it passes. So we're going from the red state, red means it fails, to the green state, which means it passes. And now we have the opportunity to iterate and to make the code better, which is called refactoring or whatever, blue face. So that's TDD in a nutshell. Every time we want to teach the system how to do something it doesn't know how to do, we create a failing expectation. We see it fail. It's very important to run it and see it fail. Then you just make it pass. And the way you make it pass is you go, because you want to get feedback as soon as possible. You can make it pass in a very, very simplistic way. You can write spaghetti code. Sometimes I even return hard-coded value just to see it pass, right? It's okay. Or we use a lot of, very naive code, something that really you wouldn't be proud showing to anyone, but you just make it pass. Then when you refactor, now you go back and you put this code into a much better shape. You avoid using primitive types such as string, integer, Boolean, but you create some abstraction, right? Something that is a business abstraction. And then once you do that, then you have your expectation fulfilled. It's passing, and you have your code clean, right? It's well formatted. Now you can move on to the next expectation. Now, what is the next thing that the system doesn't know how to do, but we want it to do? And you go like that in small steps. This is called test-driven development, because these tests are driving your development. And basically, we are never just going in and making some changes. We first always make sure that we have a test fails, we satisfy the test, we refactor and move on. And when we work that way, then what we deliver at the end is of pretty high quality. It's fully tested, and it's in such shape that subsequent to that, it's easy to improve. So, maybe you get to a point, okay, it's working okay now, but before you know it, customer or somebody will come back and say, hey, how about we add this, or how about we change that? At that point, you have two situations. One is, oh God, I don't know how to, if you ask me to change this, I think I might break something else. It's all spaghetti code, I don't know. Or you may have clean situations, say, yeah, don't worry about it. I'll just write a new test. I make it fail, I make it pass, and I refactor, and bam, you have it. Okay. So TDD is more like really small steps, and doing things frequently, right? Never letting, for example, Ron Jeffries, who is one of the leading people in this area, he says that the trick is never to let the code not be working. So the code must be always working. You should never leave like half a day, you never even run your code. That's dangerous. So anytime, any little change to the code, run it, make sure it's working. That's TDD in a nutshell from my practice.
So it actually streamlines the entire development process, and we can actually say that it's kind of like think before you act, but for development, right? You're making precise steps while developing.
Yeah. And then people say, well, okay, that's all fine and dandy, but I really don't know how to make those tiny steps. What do I do? And there's a mnemonic, or there's a formula for that, which James Granning created, another fantastic person. The formula is called zombies. And zombies, here's how it goes. Z in zombies stands for zero. So first you start with zero, which means you start with blank or empty set, or something is not there. This is your zero. Then you move to O from zombies. O is for one. Now you write test for this one instance of something. One thing is present. Then you once you do that, then you move to M. M is for many. Now you work on multiple. Let's say there's more than one customer or something like that. And then you move to B, which is boundaries. Now you're going into boundary conditions like extreme left or right. And then I is for interface, and et cetera, et cetera. You can read about zombies. But this is a really good guideline for people who are thinking, oh my God, I don't know how to write. What test should I write now? Well, think zombies, right? Start with zero, go move on to one, move to many, check the boundaries, interfaces, exceptional behavior, and simple interfaces, simple process. So if you adopt that, and it's relatively easy. The biggest challenge is to keep those steps small. We have a tendency to be heroic and to make big steps, and I want to solve everything in one. But no, the discipline. If you discipline yourself, then you'll learn how to make small steps, and these steps are safe. But in the end, they will take you to the place where everything you build is like rock solid.
Okay, so this was really informative, and I guess for all of our viewers who haven't heard about test-driven development, and it was something new for us to learn, especially your zombie code that you just shared with us. I'm sure many of us will be interested in taking up on that. Now, talking about viewers, we actually do have some questions from our viewers, so I guess we'll be entertaining them now. So,
Please.
Suvrijit Paul, he asks, with the emergence of advanced bots like ChatGPT, is it true that people will start losing jobs in the upcoming years?
Uh, depending on the jobs. Um, if somebody is hired to be like a bricklayer or just connect like Lego blocks, and a job where you're not required to do a lot of thinking but just kind of bang on a keyboard, then yes. But yeah, those jobs anyway were not very inspiring. Um, but they will never be like I was experimenting a lot with GitHub Copilot before ChatGPT came on board, which basically now just improved version. And it's fantastic, but it's always a co-pilot. It's never a pilot. So you think of yourself as a pilot. Yes, you do need a co-pilot. You do need the assistant, and you can ask it to uh, help you. But if you view yourself as being a pilot, you're flying the plane, then that job is never going to go away. There is no self-flying planes, right? And so same is software development. There is no self-driving software development. We are just commoditizing some of the chores that are repeatable. And instead of somebody going, if you think, how do I implement that? And you go search on Google, and maybe you hit Stack Overflow, or you may hit some GitHub repo. And now you're browsing, and now you're copying and pasting some code. That's what ChatGPT, only much, much faster. So you don't have to do that legwork. You just ask it, hey, write me a code for the next some algorithm, some problem, and it will write you the code. And it's pretty good, and in many cases, it's just good enough, right? You don't have to do it. But that doesn't mean that your job is going away. It just means that your job, you become much more powerful at your job, because you're thinking. ChatGPT cannot do that. It cannot understand the business domain. It cannot understand how you can help customers. It's a commodity, right? It can just give you some shortcut and can help you not to have to sweat the details and, poke around or have to debug or something. Because in the future, all that code will be pretty reliable. You don't have to worry about, oh my God, I'm not sure if this is flaky or not. But that's just, small portion of what a software engineer or software developer is expected to do. Because keep in mind, I keep telling my team, writing code and designing code is just 1/3 of the job, just 1/3 of the job. So even if you're excellent in that, you're good only at 1/3 of your job. The second third of your job is the process, mastering the process, the flow, the value delivery. There's nothing to do with code, but with interacting with the team, working with the team, making things flow, making things happen. And the last third of the job is empathy. Put yourself in the customer's shoes. Understand the problems customers are having. What are they faced with? What would they like to see? What will make their life easier and more smooth, safer? That's what software engineering is all about. So ChatGPT can never figure out that flow, how to work with teams, nor can it have empathy to understand human beings and what they really strive for and what they need to have. So if you organize yourself like that, you're irreplaceable. You cannot, there's no way you can lose your job, right? But if you only focus, I'm going to be an excellent coder, then ChatGPT can give you a run for your money. It can be a pretty pretty serious competition because it can turn quality code like this. It can beat anyone, right? So, but keep in mind that's just one part of the gig, right? So I don't feel like anybody should feel threatened by chat. As a matter of fact, it's our friend. We should just embrace it and be thankful and say, okay, thank you. I don't need to go and do some menial tasks. I hope that answers the
Chat,
question. I don't know.
yeah, absolutely. So ChatGPT will be taking over all those menial tasks for us, so we can focus more on the things that are more important.
Yeah, exactly. Exactly. It's the same as like, in the old days, I remember when I was young and working on in teams, and we had like at one project, we had 8 database administrators, 8. Because back then RDBMSs were pretty flaky, clunky. They need a lot of babysitting. They need a lot of manual. But now they have matured, and some of these RDBMSs are self-healing, self-repairing, self-optimizing. So you don't need those administrators anymore, right? It's a commodity. It's like electricity and running water. Everybody has it, and it's not a big deal. But now they moved into a much, like you say, uh, big data, much more advanced and more sophisticated areas where you can, do machine learning and artificial intelligence, understanding the data. You don't have to be doing manual chores and fixing RDBMSs or, fixing Oracle or So that's how the industry progresses. So, I wouldn't compete with commodities. You can't compete with commodities. And these all-time database administrators are not there anymore. Right? Maybe there's some corners, but yeah, it's just useless, right? But, it's like in the early days, let's say we're talking about the early 20th century when people started building high-rise buildings, and then they were, have to build elevators or lifts. And then there was a profession called a lift boy. So somebody was hired to sit inside
Yes.
and ask you, like, which floor, sir or madam. And then pretty soon they introduced buttons, and so you don't need to. Those jobs are gone. Now we walk into the elevator and we push the button, right? Basically, it's been commoditized.
So I get that answers your question, Subhrajit. Now, how about we go over some general topics? Okay, you were talking about lift boys and back in the early 2000s, which brings to my mind this rumor that I've heard about. So back in the early or the late 1990s and the early 2000s, when Luke Nozek and the legendary Peter Thiel, they were creating PayPal, which at that moment was known as Confinity, I believe. For those of our viewers who don't know what PayPal is, it's a huge company based off of US, which works with digital payments. So at that moment, when they were interviewing more software developers for jobs at PayPal, they were actually looking for people with no social life, just like them at that moment, because they thought that in order for a company like PayPal to succeed, they needed people who would give all of their time to its development. However, that was back in the early 2000s, more than 20 years back. Right now, what are the qualities that you look for in a software developer? What are the biggest green check marks for you?
I would say almost the opposite. I like people who are sociable. I think social skills, or at least doesn't have to be special social skills, but willingness to be part of the team is essential. If there are people who feel that they just don't want to be part of the team, they want to work alone, and I don't find that very attractive to me, right? For my needs, if I'm interviewing and hiring, I'm always looking for people who are interested in becoming integral part of the team, which means open to interaction, open to mob programming or pair programming, um, and learning from others and sharing, and not interested in being competitive within the team with other team members. It's not a game of competition, right? But focusing on the successful delivery of the entire team. So that to me is the most important thing, because what happens with that is people at different level of skill set. And this is something I'm noticing in mob programming session. You have juniors and intermediate and seniors and all that. But if you're repeatedly doing mob programming, there's a saying that the high tide rises all boats. And so we are rising the quality, and everybody on the team pretty much gets quick to the level where they all have share the same skills and same understanding. And anything that somebody who's a junior, for example, learns at a mob programming session, it stays with them. It is different than a learning you get from reading a book or watching a YouTube video or reading a blog post, because there's this energy in the room and there's this emotional content, emotional charge when you're with your teammates making things happen. People share tips and techniques, be it how you use some shortcuts in the editor, how you this and that. It gets picked up really quickly. And so people who are not against that type of work environment really quickly rise to a very high level of skill set, right? And then also the team, because the team is now the central thing, it becomes people become very interested in the flow of delivery. Is it flowing? If it's stuck somewhere, why is it stuck? So now they are optimizing the process, right? The flow. And also become very interested in the feedback from end users. Do they like it? Do they like what we did? Can we make it better? What do they? And to me, that hits all the whatever boxes. It's okay. We need technical skills which are quickly cultivated up to the level. We need optimizing the process for value delivery and the flow. And also we need this ability to serve customers, to understand what the pain points are, why are they frustrated with something, and how can we remove that? How can we tweak something and make it all of a sudden they like it? Yeah, and they're like, oh, wow, this is great now, thank you. So that's what I'm looking for, and definitely not interested in somebody who is just killing themselves working. And again, the problem is that there's two things we can measure. We can measure outputs. For example, in the old days, people used to measure the number of lines of code written for some time unit, or number of story points delivered, or number of bugs fixed, or the burn down chart, how many tasks completed. These are outputs, but these are meaningless because what does it matter how many lines of code are written? It doesn't mean nothing. So I'm more interested in outcomes. What is the outcome of this session or this initiative? And the outcome is not so easy to measure, because you need to kind of assess the impact on the market. And there are some intangibles. It's not always everything just about the profit margin or something. Some of these things are harder to measure, right? And so if we focus on the impact, then team becomes essential, because one person cannot make an impact, right? It's just the whole team, right? So it changes the perspective. And all of a sudden we are not, there's a saying, there's a race called relay race, where there's a baton and the racers are running and passing the baton, right? So in some companies, they keep an eye on the racers and they keep track. Okay, you were running this much, you were sitting on the bench. But some companies keep an eye on the baton, because it doesn't matter how hard somebody is running or not. If the baton is not moving, it doesn't matter. So value is like this baton. It has to keep moving and it has to be reaching the finish line, right? And then you can let the team self-organize and decide how they're going to deal with this, and they're going to deliver. But it's important to make it clear what is the expectation. What are we expecting as an outcome or as an impact? So I hope that answers the question. And it doesn't matter if somebody is working 15 hours a day, or that means nothing. There's just metric that. But where's the outcome of that, right?
Yes, sir. It beautifully answers my question. But you heard it here first, guys. Be sociable. Okay, work with a team, and that will be your path to success.
Yeah, yeah. Think of it. I think of it as almost like theater troupe. Like you have actors, and you need to deliver the play in on the stage, which means everybody has to be on the stage. You cannot one by one go and recite your lines and then go, right? Which is how some people work. But the whole team on the stage and delivering lines, bouncing off each other, dialogue. This is how teams work. Or a sports team, like in basketball, you have to be on the. Some people are really good at shooting hoops, and they can brilliantly every time they just. But that's not how you win the game. If they don't want to play with others, just being brilliant at shooting hoops is not going to win the game, and they will not be hired to be. So you need to be what we call the skin in the game, right? On the court with your teammates, passing the ball, interacting, communicating, collaborating, making things happen in real time, right? Working asynchronously is very powerful.
Well, that's a really beautiful summing up of the entire situation, Alex. Now, I hate to be the one saying this, but we are actually nearing the end of our session. We don't have much time on our hands today. So, this thing I would like to ask: is there anything you'd like to give as an advice to all of our viewers who wants to become a product manager someday or wants to work with teams developing software solutions?
Um, you know, I can say one thing which is really tricky, which is we still don't have this situation where the team is given enough agency and enough authority or autonomy to work as a team. For example, I get hired as a manager, and then I get asked to interview and hire people for the team. And so once you do that, you end up hiring somebody, you like them. But now the expectation is that I have to keep track of that person, that individual, because I hired him or her. But I don't like that. I think that the team should keep deal with that, right? And even one more, I feel like the team should be interviewing and hiring because they're going to be working with this person. They know who is a good fit, not me. And that's where I see still, I would like to see teams get more involved in the interviewing, hiring, as well as dealing with issues. If somebody's on the team, not pulling their weight, slacking, not attending sessions, then the team should have intervention, say, hey, what's going on? You're pulling us down. We cannot afford that. Can we help you in some way? What do you need? Do you need this and that? And if that doesn't help, then the team should have the power to say, okay, we don't want this person on our team. This person is slowing us down. This is to me what I would like to see in the future. I'm not sure if this is going to happen, but again, if you want to work as a product owner or whatever, right, somebody who is managing the team, then we need to recognize this power of collaboration. Sometimes people confuse collaboration with communication, and when I say, well, I don't see much collaboration, and they go, no, it's not true. We are sending emails, we are sending messages in Slack channel. That's not collaboration, that's communication. You're communicating. You are creating diagrams and documents you're sharing with others. That's not collaboration. You're communicating. Collaboration to me means all hands on deck. You're present right there. Bias for action. We're collaborating. We're making things happen. We're fixing things. We're improving things. We're face to face, like here, working with each other in real time. This is what is still the challenge because previous generation has been trained to everybody go into their own corner and just work in silence. But now things are changing. We are recognizing this is not good enough. So for people who want to work with software teams, there is a saying, managing software developers is like herding cats. You try and train cats and each cat goes into their own corner. They don't care. But this is not how people are. This is how they've been conditioned because they've been asked to go into separate corners. Because here's your ticket, here's this person's ticket, just go away and do work alone. But if we change that, and if we now expect the team to work as a unit, then people will change. And it's not the problem is not in people. The problem is in the process. People will change, and they will take the opportunity and advantage of that. And so if you're looking into going into that role, I would advise you to create a situation where you're not individually assigning tasks to team members. That's not good. I find that to be bad. But put expectation in front of a team, saying, okay, we want this to happen. Let them figure out who's going to do what and how, and they know they will find a way. You don't have to worry about it. But if I spoon feed people, first of all, it's patronizing, right? It's condescending. I'm treating them like children in kindergarten, and people will be just like, oh, okay, whatever. But if you give them a challenge, you say, okay, here's what I expect to see, go and make it happen, then you will see how people self-organize. They'll find way, and they will enjoy it more, and will feel like grown-ups, like somebody who is respected, who is a professional and capable of delivering real value, which is what people are there for. So then sometimes they go like, okay, we need to talk about how do we motivate people. I don't think we need to do that. I think people are already motivated. All we need to do is stop demotivating people by micromanaging, by giving them, spoon feeding them. You do this, you do that. Are you done yet? Why is, what's the delay? Blah, blah, blah. That's demotivating, right? And people get to the point like, I don't care. But I believe that people apply for a job, get a job, that they are motivated. That this is how human nature is, right? Very, very unusual. Somebody will be just faking it, and very rare, very rare. Most people honestly apply for a job, get it, happy to get it, motivated, and then they learn like, oh, they're spoon feeding me, they're asking me every 5 minutes, is it done yet? Is it done yet? And people lose their spirit. So my advice is don't do that. Look at the team as the unit. The team is going to deliver the value, not individuals, right? And then another problem is, of course, with performance evaluations. Now, how are you going to evaluate if the team is the smallest unit? So all these things are still under examination and under transformation, but I believe that the social aspect is the most important aspect. I don't know if that answers the question.
It absolutely does. Work with a team, have a close connection with your team so that you guys can work in unison and you will
Yeah,
be making greater results, right?
yeah. And you will actually, by doing that, you will end up with a resume. You can ace any interview. And if you're in a position where you know you can ace any interview, you're not nervous. You like your team. People get nervous when they think, oh my God, like I've been here and I haven't learned anything. And meanwhile, other people have advanced. And now how am I going to get another job if this doesn't work out, right? That's demotivating. But if you're working with a team, you pick up all the skills, you have a brilliant resume, and you can ace any interview and you're relaxed. That's very important also. And giving people a chance and giving them an opportunity to sharpen the axe, to improve their skills. Because, I think Abraham Lincoln said, if somebody gave me 1 hour to chop down a tree, I would spend the first 50 minutes sharpening the axe. Right?
Yeah, absolutely. I've heard
Yeah.
that before. So I guess this marks our end of today's session. I want to thank you so much, Alex, for giving us some of your valuable time and sharing your
Thank
experience with
you.
us. I'm sure this has marked change for so many young developers, and it would give them a way to follow in the futures, right? And
Yeah.
for all of our viewers who are watching right now, if you want to connect with Alex, you can check out his LinkedIn profile. It's given down in the description. And I would also like to thank all of our viewers for joining us for today's Dev Talk session. So this is Dev Talks. I'm Partha Banerjee. May the source be with you.
Bye. Thank you.